Welcome to this Architecture Today webinar with Schüco, Sustainable Facades. Your chair, Ruth Slavid, will be along shortly, but let's get started with Schüco UK's Commercial Director, Sean Butler.
Welcome to the latest in our series of 80 Schüco webinars. In today's webinar, we will look at the key role facades can have in improving the environmental performance of buildings while also keeping their inhabitants comfortable, healthy and safe. We've got three expert speakers who will each outline the work they've undertaken on three very different facades and explain how their designs contributed to the sustainability of the overall project each was involved in. We know that buildings cause more than 40% of the CO2 emissions in Europe, and we believe it's critical that we massively improve the performance and efficiency of all buildings. We believe sustainability means designing, constructing and operating a property in such a way that it is ecologically, economically and socially future-proof. And we are fully committed at Schüco to providing outstanding products and solutions for sustainable buildings. I think today's presentations and discussions will raise many crucial issues for all those interested in the challenges of the future and our ability to employ resources and materials in a reliable yet ecologically and economically sensible way. Thank you once again for joining us. I'll now pass you to Ruth, who is chairing today's event.
Thank you, Sean. I know this is really important. We all talk a lot about fabric first, and obviously the facades are such an important part of the building fabric that if you don't get those right, you won't get the building right. Before I introduce our speakers, I'd just like to remind everybody that we do have opportunities for questions, both briefly after each of the presentations and also time for a longer discussion at the end. So if a question occurs to you, do please use the questions button and send it in. My advice is to send it in when you think about it rather than forgetting it. And we will look forward to a lively discussion later. But we are about to move on to our first speaker. We've got a great set of speakers today. We are going to be hearing a little later from Mark Tynan of Make about a great mixed use project, and also from Carol Patterson of OMA, who's going to be talking about their work for Brighton College. But first of all, I'm delighted to be introducing Sandy Wright of Wright and Wright, who is going to be talking to us about St John's College in Oxford.
Thank you, Ruth. Firstly, I would like to thank Architecture Today and Schüco for inviting us to participate in this event, Sustainable Facades. As Ruth said, the building I'll be talking about is the new library and study centre for St John's College in Oxford. The college is located on the north side of the city centre. It was founded in 1555 by Sir Thomas Wright, a wealthy London tailor merchant. The first quadrangle, front quad, was followed by Canterbury quad. Canterbury quad was funded by a former student at the college, Archbishop Laud. He came to a rather sticky end in the Civil War. This illustration of Logan's shows the entrance, the front quad with the chapel and hall, and beyond Canterbury quad with the old library and the Laudian library named after Archbishop Laud. Beyond are the gardens, Sprott's Wall, which I'll touch on later, and this orchard at the time, which became the President's Garden. The context and site constraints were quite considerable. And highlighted here is Sprott's Wall, which the building is placed against. This is a listed wall, and we weren't allowed to perforate it, and it's about 5 meters tall. To the west is the President's Garden, and the constraint there was that we weren't allowed to have any windows looking out over the garden. Further concerns of the college were that the old college buildings down here had become a bit remote, because over the years they had expanded quite massively in the north area, Kendrew Quad and Garden Quad. And they felt that the centre of gravity of college life had migrated away from the old core where the college began. So they wanted to, if we could do something about how to restore that link. This is Canterbury Quad, and it's regarded as one of the finest examples of English Baroque architecture. What you see there on the axis looking out to the Great Lawn through the arch is the Laudian Library. And above the entrance in the centrepiece is a statue of Charles I, who was there when the building opened, and allegedly the opening ceremony lasted a week. The two existing libraries is where our study began. This is the old library, which now houses the rare books. And this is the Laudian Library, which houses, seen up here, which houses the student readers, but not that many readers. The old library was under great pressure for archive and storage space, so that had to be part of the brief. And obviously at the Laudian Library, with only 30 reader spaces, they wanted many, many more readers, as many of the college libraries are now demanding. So how could we reverse the plan and maybe open up the potential for expansion to the north, and in so doing, reconnect the college? These three plans show the 1603 plan with the entrance to the old library, and then the Laudian Library was built. A staircase was built in the corner in the 1970s to try and answer that problem. And then our proposal was to try and see if we could make a link to the site to the north. And we did this, we discovered a store in the cloister called the Otranto Passage. And it led from Canterbury Quad to the north, where we built a new staircase. And that in turn solved many of the problems of opening up the potential for the new site and solving quite a few fire and access problems to the existing library buildings and to the future building. So this is the Otranto Passage, and it was we built this route into the corner accommodation. It was an opportunity to continue the college interest in art. So they asked Kirsty Brooks to install a piece of work that recorded the college history in an abstract timeline, that runs the full length of the Otranto Passage. And her work is very beautiful and very abstract. And here's a picture of us looking at the mock-up that she made for us before the installation was made. So we built the new staircase and then opened up a doorway to the north to the Laudian Library. The archivist at the time showed us this drawing you see at the very top. And this was an opening that had long been sealed up and people didn't think had ever been built. It had been built it was the entrance that Charles I walked into the Laudian Library. So it was a very important entrance, but it got lost in time. But when we opened up, lo and behold, we found the remains of that opening. So we restored and rebuilt new stone to copy that drawing. So we'd restored an historic link. So to the site, and it's a tale of two walls, really. One wall is Sprott's wall that I've described to you to the east, and the other wall is the staggered and stepped screen wall to the President's Garden, neither allowing any daylight through them. No windows could be allowed in the walls. So you see in the photograph on the right, the Sprott's wall being propped, and then in the footprint of the rebar coming up from the base slab, the outline of the wall to the President's Garden. How were we to solve the issue of bringing light in? So what we proposed was to center the bookcases down the middle of the plan. And in the spaces in between the bookcases and the respective walls, we would place the readers and somehow deliver daylight to them. And that was the solution. Our interest focused on the stepped wall to the garden, and we suggested to the college that this might, or part of it might be a great artwork. And after a competition, Susanna Heron was appointed to design a huge sculpture, which you see laid dry here in the factory where it was made. And it involved a great journey through testing how we light her wall, how we selected the stone, all the mock-ups that she built. And it ended up in this device. So this is screening direct view into the President's Garden and is a low relief sculptured wall. The outside is slightly deeper relief than the inside. And because it's north-south, the time, if you ever get to visit the building, to come is to come around noon. And the play of light and shadow over that wall is quite, well worth the visit. Another constraint that we had was that we had to distance the users of the garden from the readers. So we introduced a moat that maintained that distance. It also allowed us to indulge in something that we'd seen at the Alhambra Palace many years before, and that was caustics, which is the play, as you know, is the play of light through slightly agitated water. And hopefully you can get the feeling of that from these two slides. Even some bird songs thrown in. To the north end, if you recall then, we made the connection through the building, through a cloister through the building. And the north end, we created this sheltered space, which is a meeting space as much as an entrance. It's the north portico. And through there you see in the distance the view of Sir Philip Dowson's Thomas White quad building, built in the 60s. This is the view back from the north, looking at the new building, again addressing an existing garden wall. And above there, you see the seminar room, which is an autonomous space with the ubiquitous corner window, but with some huge windows, some Schüco windows, I'm glad to say, that slide back and expose great views to the Grove Gardens, which is the student garden, and across Thomas White Quad. On to sustainability, the building fabric was designed to be airtight to reduce uncontrolled infiltration and unwanted heat losses. And at the time, we went significantly beyond building control targets. Natural ventilation to the main library space is carefully controlled by a mix of windows and louvers, which open and close according to the internal conditions. And they are controlled by the BMS system. The college also asked, though, that the users would have the ability to override the BMS system. So if you wanted to open a window, you could do that. The building is passively controlled, and fresh air is brought in through this linear plenum here that you see. So it pulls fresh air in from small courtyards at the north and south end. That air pours into the bottom of the section, as it were, and is heated, and rises up through the section and out through chimneys that are concealed in the roof. The top reading room is a slightly different arrangement. It's got cross ventilation and uses clear story and skylights, but also affords great views out over the lawn and over the groves. We also looked at a wall for artwork, which has recently been installed. We haven't seen it yet, so we're going to see it next week. And the Fordhams were a great help in helping to design the lighting for that. Also, we needed to introduce some fins to block out sunlight, and you'll see these located on the sloping glass roof to the lower reading room. The building structure is predominantly concrete, and many of its soffits are exposed, so that gives a good thermal mass, which we use to balance the environment. It also works in combination with night cooling. So the windows are open and closed at night and allows the whole building and structure to cool down, ready to absorb heat the next day. Below ground is the archive, which takes the strain off the old library, and here are the rare book collections from all a fantastic collection of books and artifacts. It's just a black box, but again, is a passively controlled archive, and it's super wrapped up and very, very airtight. Here are images of the reading space. So this is the lower reading room. On the right, you have Sprott wall, and with the top light and the fins I referred to earlier. Off to your left is the linear plenum, and that brings fresh air in at low level, and it slowly finds its way up and out a chimney at the far end of the plan. Up there is the mezzanine floor, and that is the view that you have over the lower reading room. And this top view is the upper reading room, and that's the top of Sprott's wall that you see there, and these are great views out. So you're up in the tree canopies looking out. There's very good light in here and very good cross ventilation. And to end, and it's perhaps a strange note to talk about sustainable facades, but we are now tasked, now that that building is complete, we're now tasked to renovate and upgrade the old library and the Lodin Library. So it's quite to go back in history and see what we can do. And of course, it's a balance between improving performance in the environment, but recognizing the historic fabric and doing it in a very delicate way. So we're blessed with a great pool of expert craftsmen and women who make mock-ups for us that we can test and get approval from the college and obviously from the planning authorities. And that's what we're doing now. And this building will be complete in 2 years now. It's on site now. So these are some CGIs of the spaces as they will be restored. All the lighting is improved, and the windows have secondary glazing. And there's a new exhibition, sort of museum end to the old library, where exhibits from the archives are put in more permanent display. So we're looking forward to that completing in the spring of 2023. Finally, to end, this is the view of the building from the President's Garden. Thank you.
Thank you very much, Sandy. I'm really interested in the collaboration that you had with an artist, with Susanna Heron. And I can see that there are huge advantages in doing that. I wonder also how difficult that makes things when you have an artist involved in such a very key part of the building and a key part, presumably, of the production schedule.
Well, historically, I know from other architects and stories I've heard, it's that there have been problems trying to fuse art and architecture. But I have to say, after slightly nervous introductions, we got on very well with Susanna and her team. And she could understand some of the building constraints. I mean, she understood that there was rain falling on her sculpture, for instance, and that we would keep it out. So she was very understanding. And I think one of the most exciting and recommended ways of solving it is if you build lots of mock-ups and test things with her, it grows up in confidence. I see all my colleagues, the architects, nodding here. I mean, that's the way to do it. And you build up confidence in that you can see nearly the real thing emerging. Like lighting, we had buckets full of light fittings playing with Max Fordham lighting engineers to see how to light and get caustics to work over the stone walls. So for me, this time, touch wood, as it was with Kirsty Brooks, it was a very pleasant journey. And the two things almost made the whole better. The art was good, the architecture was not so bad, but the fusion of them both made the thing so much more exciting.
Well, I think we'll accept that the architecture was not so bad. I'm also interested in. I love the phrase you used, "a tale of two walls," and I thought it's interesting that you did have these constraints, which meant apart from in that reading room on top of Sprot's wall, you really couldn't have a lot of direct light coming in, and therefore you didn't have a lot of views out. Do you think that's particularly suited to a library building, where you really want everything to be fairly contemplative, or would that sort of approach work well in a different building as well?
Difficult to answer the second part of your tricky question, but the first part's easy enough. I mean, there's plenty of classical libraries have clear story top light. I mean, one of the most magnificent ones I remember being shown by the bursar of the day was at Trinity College in Cambridge, and the great top light floods in, so you read it, lights the books. You don't get much of a view out apart from seeing the sky and the clouds. So that works. You're there to study, and I'm glad to say students don't stay in their bedrooms. They do come to the library and use the library. I think they need to leave home, as it were, and go to a public space in the society of rooms in a college and get on with a day's work. The top lighting in other buildings, we'd have to see the program. This is a pretty unique program, being given a site with the two long elevations not being allowed any daylight. But allowing daylight in is something that and drawing sections is something that we're very interested in. I trained in Gillespie, Kiddincoya, who did about 30 churches, and all those churches were based on the sections of how you brought light into the altar and how light rotated around the space. So I think subconsciously one is influenced by that sort of experience working in those types of buildings.
Well, that's really interesting, and of course, I suppose that is another building type, isn't it, where you're supposed to be looking internally rather than
Yes.
looking out.
Yeah.
We'll have a chance to have a lot more questions later. We'll have that in discussion with the other speakers. But our next speaker is Mark Tynan from Make, and he is going to talk to us about a very, very different building type, rather less contemplative, I think, but equally fascinating. So over to you, Mark.
Well, thank you to Architecture Today for inviting Make to present our project 80 Charlotte Street on the topic of sustainable facades. 80 Charlotte Street's recently been completed in Fitzrovia, just behind Goode Street Station. It's a mixed-use development comprised primarily of offices at 80 Charlotte Street and residential blocks on the conservation area of Whitfield Street, which includes social housing, private rented and private sales. The building comprises about 320,000 square foot of offices over 10 stories. It's got 3 atria and play of natural light and ventilation, plenty of external terraces. It utilizes reused facades along the conservation area side on Whitfield Street, which become part of the office as well as predominantly the residential components to the site. We've also introduced a pocket park on the south side and lots of thought around how to make the commercial building flexible, adaptable for long use. The residential blocks on the southeastern corner of Whitfield Street comprises about 43,000 square foot of residential, as mentioned, sort of residential use of private and affordable, which comprises of about 55 units, using the existing structure as well as facades on those two buildings. The original site had a 60s block, which was home to Saatchi and Saatchi. When it was built in the 1960s, it was for the post offices. It's comprised of mainly sash windows with mosaic spandrels of a concrete and masonry construction. As you go from Charlotte Street around Howland Street here, as you hit Whitfield Street, it's got the retained facades, which we'll go into a bit more detail on later, which form part of the commercial in the middle here, as well as the residential elements on the left side of the image. See the buildings made up of different styles, different eras, from the 1960s residential blocks through to the 1930s residential blocks, 1960s commercial blocks. Different heights, different material treatments, very Fitzrovia in terms of small, different era buildings that make up the Fitzrovia village feel, the area. So our approach to sustainable design for this particular project, and perhaps as an overall approach to projects at Make in general, is to try look at 6 principles. Embodied carbon is a big topic. Types of material you use, types of the operational energy behind it, environmental factors, recycled materials, greening, that extends to things like well-being, having flexible design to create community and activity to the area, as well as flexibility and connections within the development, mixed uses, and then the green economy in terms of how the operational costs work over time, the life cycle costs of that building in operation through its lifespan. And these, of course, break up into various sort of subtopics in themselves, and we would tailor and tune those to the different sites, different sites, and different environments that our projects end up being in. As architects, we feel, thinking about carbon at the early stage is very important. The embodied carbon in the materials we use or maybe reuse, in this case of 80 Charlotte Street, how efficiently that is designed in its layout and form, the geometry of the facades to the fenestration, the glass and solid ratios of those particular elements as you orientate around the site. As well as you see on this table, that's where the biggest amount of sort of embodied carbon could go into. On the right-hand side is your body carbon sort of materiality, and on the left-hand side, you've got these sort of operational. When we think about facades and its embodied carbon, your sort of typical glass box on the right of the charts have quite high energy consumption, not through just its manufacture, but also through its energy use in the actual building. Very glassy facades are not very energy efficient. Lots of solar gain, lots of heat loss. And you have to bump that up with mechanical components. So moving down the chart and trying to work towards the REBA sort of climate challenge of 2030, we feel more of our buildings are introducing solid materials, solid components, such as masonry, concrete, and timbers, which introduce more solidity to the building, but also have some sense of renewabilities, especially timber, not particularly here on 80 Charlotte Street, but with the precast and masonry buildings, and of course the reuse of the existing facades on our site help to reduce that carbon. Also introducing materials, especially the masonry and the concrete, materials that last longer than your sort of typical 20-year design life, moving it towards 60 plus where we can. That has a big sort of carbon sort of by thinking about longevity of the materials we choose. A key point is, of course, the balancing of glazing ratios. We've historically sort of worked towards away from the glass office block towards more solid buildings. Here we've got 5 Broadgate, which is predominantly a solid, well-insulated elevation of about 35% window-to-wall ratio. Another project in Birmingham where we got Arena Central, 40% wall window ratio, and of course 80 Charlotte Street, where we're at also 40% by introducing these masonry and precast elements and keeping a solid spandrel. What that does is enables an optimization of that facade in terms of solar gain. You reduce that by about 20%. and just by introducing a bit of solidity at the bottom, and then controlling that around each orientation of your buildings, the north, south, west, and east elevations. Also, from a visual point, you often see lots of office clutter against those full height glazed office components. So actually introducing some solidity helps tidy up your elevations, and it's worth considering from a commercial perspective. There are sort of beneficial components to this thought process. Of course, reuse is always on the table, especially with inner city projects where we rarely start with a blank canvas, and that premise falls upon the client whose early project included the T building, which reused that old light industrial building in Shoreditch for offices and other uses, and our early project at 55 Baker Street, where we adapted the old post office buildings there for new office use by inserting new elements, new cores, and new floors. As mentioned earlier, choosing materials that have long life is critical, and also materials that have a self-finish, which you express and expose and make part of the architecture, both externally and internally, helps towards that goal of reducing carbon, and also through unnecessarily additional finishes. So when we take that approach to the site, this is an early aerial photograph of what was once there, and taking on board the topics of reuse, recycling, and reducing materials. We started by looking at a way of infilling the central core that you see there with a new central courtyard with a new central core and atriums, which would provide connectivity, light and ventilation to the inner parts of the office space. Where we can and where we have done, reuse the structure and facades of the residential blocks on Whitfield Street and the retained facade of 71 Whitfield Street for the commercial components. Here we pushed and pulled the volume around this site context, introducing setback terraces, introducing breaks in the form, much akin to the existing building, but also much akin with the wider Fitzrovia context. And then treating the fenestration along those facades from tighter fenestration, smaller windows, and more solidity on the southern elevations to bigger and wider windows on the northern and eastern elevations. On top of that, there are, of course, the wider sustainable targets of renewables, fresh air, daylight, rainwater harvestings, and PVs and such, which combine to create a building that has an embodied carbon of 1,100 kilograms of CO2 per square meter, which actually we improved on by 28% at practical completion. A building that is net zero carbon ready by way of being all electric with our renewables, by sourcing energy from sort of green energy sources. Very much an emphasis that the client pushes themselves. There's no gas supply in the building. The facades, like we mentioned, reusing those facades where we can, optimizing the daylight penetration or minimizing daylight penetration by introducing that solidity, and they're going with that 40% wall to wall ratio, and other aspects such as well-being, making buildings that are you want to be in, that hopefully will then last the test of time, and of course having flexibility within that, so that can be used in hopefully generations to come. So that's the building overall. That's what we've designed so far. As we go around the facade types, you can see the smaller fenestration of the brick building on the Charlotte Chitty Street corner, to then the precast on the left. Solid spandrels up to about 800 high to keep that window wall ratio down, choosing materials that have that long life, and also a thermal mass. So it takes longer to heat up and sort of releases that heat over time, over the night. So that thermal mass, that thermal inertia within these solid elements is very important to factor in as well. We've also, by doing what we've done, we've improved thermal performance from the original building by almost sort of 40% and more in places, where we've got three main types: the masonry type you just saw, with the smaller windows, with a curtain wall zone at the back, with that solid insulated spandrel on the base, to the precast frame on the northern elevations, to then projecting bays where you can push the facade out. You don't need those reveals. You don't need to worry too much about solar gain on those northern elevations. Windows can pop out. Designing those facades to be modular, prefabricated, so that it can be controlled off-site, and also you can control the amount of material used. We had the option of making it extremely flexible, so that the facade was one structural component to the primary. It's self-standing, self-supporting, so that should the building change in the future, the facade could stay in place potentially. So thinking about that, and that really came about anecdotally through the 60s building. We had originally planned to reuse that structure and just reclad it with the systems I've just shared. Of course, in itself, a topic on how you work, how you get the floor plates to work, how you get the systems to work in what tends to be quite lower floor ceilings in the buildings. But when you do this, you have to really put some time in and effort into investigating the existing structure. And what you might find is that the original design spec that it was designed to may not have been built that way. And of course, wear and tear over time, you might find that, and certainly in this case, we found that the structure, the rebar was exposed, and there was corrosion, and a lot of work would have had to be done to get work. So unfortunately, we had to knock that building down, as you see on the left here. The residential and the retained facade along Whitfield Street in both facade and structure. Back onto the facades, there's other aspects to throw in: having openable windows, having a mixed mode service system, so that you get fresh air and give the tenant the option, especially maybe in this climate, the ability to open a window and get some fresh air in, and of course then trigger the services to turn off in that perimeter condition. That means that you have to design the core so that the facade to wall ratio is always kept down. We're no more than 20 meters from a point of light, point of fresh air. When we come to the retained facades, as we can see here, we sort of kept the structure on the residential blocks and the facade of number 71. We added floors where we could, and replaced the windows in this instance. But there's a few considerations to factor in. You know, levels are always different. Older buildings have smaller floor ceiling, or they have diminishing floors. So you might find your new floors don't quite meet, and you have hit and miss windows when you find the new meeting the old. You have to think about the sequencing of the structure, how you prop it up, how you demolish it, and then of course how you then integrate the new structure around it. There's a lot of investigation and unknowns, so strengthening of the steel structure, strengthening of the existing structure, lots of repairs, and a lot of work to maybe even replace rebar in this case. It's very important to get a condition survey. You can see here lots of cracking and lots of damage over time for these older buildings, where we marked out where all of those elements occurred to then test out how we would replace and repair that brickwork. When it comes to the intervention of new, we have the sort of new windows which improve on the insulation, but also lining the back with additional insulation. You're going from a sort of a cold cavity through to a now warm building, and working around the existing structure. That additional zone you might need to allow for within that building. designing around the existing. So you might end up with features of existing column that form part of the design, working around that, integrating services around those drop beams, and being playful with how you set your floor ceiling heights and insulated backs to those existing brickwork. Or where you can see here, we intervene with new blockwork and new insulation at that back. You might get some dispensation in terms of windows, where certainly in the conservation area, the council might have their own sort of particular preference. They might be lighter in touch in terms of Part L, in this case, allowing us to do the critical windows on Whitfield Street. And how you integrate the old and new together, as you can see in these photographs. And utilizing recycled material, recycled aggregates from the demolition, and interfacing that with the new build. I thought to do a quick tour of the site as we go around. So we see that of Charlotte Street, the brick and masonry buildings. Do then the precast as we go around to Howland Street, where we have the recessed windows on the southern and western elevations, so then the projecting ones where we are starting to face north and don't have to worry about solar gain too much. As we then turn the corner onto Whitfield Street, where we start to see the retained buildings. Entrances where the hit and miss floors, we introduce with slot atriums. To then the residential blocks of Chissy Street, Whitfield Street, and Astor House, where we integrated sort of, where you can use sort of existing features, the new apartments, and of course additional story heights at the top. The Purpose Park in the middle, which gives an element of well-being, connectivity, and sort of communal uses, and taking you inside the building. You then have through the entrance the continuation of that material honesty through the sort of bringing of the masonry work, taking you down, exposing materials where we can, being clever with finishes, to then introducing volume and light through into the space. Having community uses. And then onto the floor plate, continuing that sort of essence of simplified materials, adaptable for long life and use, reducing the waste and using that thermal nurture as we did on the outside as well as on the inside. So that it gives the tenants the absolute flexibility to design what they want within the building, which then gives that opportune moment for sort of long life and long uses over time. Breakout spots, connectivity. And on the roof, you've got the renewables, you've got the beautiful well-being roof terraces at the top. And then this lovely pocket park. Thank you. Sorry, that was quick. Thank you.
Thank you very much, Mark. And you showed us a really complex project in the time you had available. I'm going to ask Mark a couple of questions in a second, but before I do, I would remind everyone who's watching this that there is still an opportunity. Do send in questions for Mark and for Sandy, and we can tackle them at the end. And obviously, when we hear our final presentation, send in questions there as well. So Mark, I wanted to ask you about this whole question of all the work that you have to do in terms of lining up levels when you're retaining buildings, in terms of condition surveys, and even things like working out which demolition materials you can use within your new building. I mean, compared to doing a straightforward new build on the site, it seems quite complex. Is this actually reflected in the fees that you get?
Yes. So, you know, I'm probably not best placed to go in detail, but you know, from your sort of typical 4.5% for a commercial building fee, we've bumped it up with the retained elements to 6, and with the residential 8%. So you have to get the client to buy into that. So you need a brave client that's sort of willing to do that, and Derwent certainly were. You also then have to factor in the time, that additional program. As you saw with the investigatory work, you have to explore what that building can do based on the ideas we put forward, which goes back to what Sandy was saying. Like, mock-ups are critical. Mock-ups, testing, investigations are very important to sort of test our ideas and to see if they can be implemented. There's our fees. There's also specialists. I think we had to get some specialist consultants, masons that sort of knew how we could repair, fix, strengthen those existing structures and repair the brickwork, as you saw. So both on an engineering side as well as sort of a heritage side. So there's a few strands and layers you need to factor in to bolden the team to tackle this sort of reuse challenge. So that's sort of broadly speaking, and not forgetting, I slightly hinted at earlier, we did look at a refurb, a reclad option of that old 60s block, which ultimately, sadly, through a pre-contract service agreement, which we worked closely with the contractor to test when the building became vacant, to then sadly realize a lot of those structures were sort of past their sell-by date, and of course we then had to ultimately redesign the new steel structure that I showed you. So additional fee, a bit more time in doing so.
Another question that came in was just asking if you can explain whether it was to do with sort of orientation with passive design or whatever, how you decided, given that there was going to be there were going to be offices on the site and there was going to be residential, how you decided which parts were which.
Well, we felt certainly, again, conveniently using the context. Whitfield Street was a quieter street from a traffic perspective, so that it had smaller windows, sort of structure that we reused, lower floor to ceiling, which actually favours a residential change of use. So you could get away with a 2.4 floor to ceiling compared to what the building council offices pushes for an office, which is sort of 2.7 plus. So you're talking sort of 3 meters clear floor to ceiling, which the old 60s block didn't. So we squeezed that down 2.6 when we did do that version. So the Whitfield Street blocks became suited to the residential use. It's on the quieter conservation area street, had the smaller windows, so it sort of easily tied into that change of use. So that seemed very, just convenient and a clever use of those buildings. The commercial buildings on Charlotte Street, using a bit of intuition in terms of south-facing smaller windows versus larger windows to the north, but also looking at the context of Fitzrovia. So further down Charlotte Street, you do hit the Georgian townhouses, smaller diminishing windows, series of smaller individual fenestrated openings, which you then see replicated in our masonry block in the corner, to then opening up further north along Charlotte Street to the sort of the BT towers, the glacier buildings of the Arab buildings along the road, which then allows us to transition from the smaller, tighter fenestration of the Chissy Street corner through to the larger windows on the northern side of Charlotte Street. So using the context again, trying to go from small to large, using the urban grain within our context, which then also plays into how we set the various floor levels back. So on plan, it is a big building on plan, but externally, by breaking the building down, by setting the floors back, we try reduce its sort of visual bulk and mass in Fitzrovia itself.
Our last speaker is Carol Patterson from OMA, and she's going to be taking us to Brighton and to Brighton College. Carol.
Thank you very much. I'm going to tell you a little bit about the building of Sports and Science because it's related to the facades and how the design comes together. Before I get into some of the detail. The project is at Brighton College, which is located it's actually central Brighton in Kemp Town, but only just a couple blocks from the beach. And this building actually gives, at the top, gives views of the sea for the first time from the campus in its 200-something year history. 200 years? 350, something like that, sorry. The campus is actually, as I said, so 1845, is quite historic at the front, and that was an original building by Sir Gilbert Scott, and then an extension by one of his disciples, with the playing fields at the rear. Over the course of history, so this is the Sir Thomas Jackson, who is the disciple, and this is the street front elevation. And over the years, along the side, new buildings were built in the 60s, 70s, 80s. The campus or the school took on a master plan about 10 years ago to replace those buildings with something more akin and kind of at the same level of degree of the original buildings. Our site is these areas 4 and 5, which are here along the playing field. So that's actually a rugby game in process, and I'll just have you note the row houses that's opposite our site, the street surrounding. And the brief was for sports and sciences. The intention was really that you have a sports building and a science building with an atrium that link the two together. However, we decided to join them up into one because there's a relationship we felt between sports and sciences, and it'd be great if the jocks and the brains could actually have more of an interaction on a daily basis and recognize maybe the commonalities between their disciplines. So this is sort of a diagram of the building. In the yellow is the sports, which are on the field level. So that's actually the level of the playing field here. And the sciences as kind of a bridge above. Again, that's a bit of a zoom in there at the science over the sports. The sports activities obviously needing large span spaces over the swimming pool and the gymnasium. This was an inspiration about the facades. Because of these buildings opposite of us, and because the building is so long, we wanted to make this kind of cellular nature of the science buildings. So this is actually further exemplified here, where you have these strong party walls, which are really evident when you come into Brighton, particularly on the train. And then the beach structure. So we came up with what we call the skeleton, which is really then spanning over these large sports spaces here, which are equivalent with the playing field. And then the science labs are really lab and cellular in nature. These are a few examples of the other buildings on campus. And we chose to make our building in a black or anthracite fiber C. So it's a GFRC-like pre-made GFRC product. So this is what was there before, sports hall to the left, and then just a classroom building to the right. And then this is a couple of months ago. And when the building was finished, it was nice and wintry. Also, the circulation through the building is quite organized in a way that there are two levels. There's really the level of the playing field, which we call the field level, and the level of the campus, which we call the campus level. So if you're playing sports, you would come in at the campus level to where all the locker rooms are located, and then access your sport, adjacent sport, which is either swimming, or you come up into the gymnasium, or up actually, there's a field entry for muddy boots straight to the field. Sciences and others would come up this main staircase, exterior kind of amphitheater stair, and enter the building. And then there's a series of staircases and of course lifts, which bring you up through the building and up to the roof, which then again steps up and terraces up to an occupiable roofscape. So just a 3D version of that. So the field level, again, the big sports, which break out onto the playing field, the sports hall, a big conditioning room, an aerobics room, and a cafe that has an elevated view over the terraces. Here are some views of that. And so the idea is that because these staircases actually move up through and step up and slope, you get views through to the different activities throughout the whole process of walking through the building. So this is a view on the stair looking through the aerobic studio out to the playing field. This is looking back into that aerobic studio, the playing field in the background, and the swimming pool down below you. This is actually a reflection in that aerobics room, where you can see the playing field and those brownstone, not brownstones, but townhouses, and staircase, cricket nets in the sports hall, and that's a view of the sports hall from the level above, because you can again see from the level above down into the sports hall. And then the lower levels is primarily changing rooms. Again, you have access to the field and access to the wet changing for the swimming pool and the sports hall. Just a few views of that swimming pool. And again, there's opens and atriums, so you can see up and through the building throughout. And then we start to move up the Science Bridge, which is then circulation. There's grand breakout spaces and circulation spaces at all levels. That partly came in a brief from the client to be able to have enough space for students to circulate without getting crammed up in a corridor, which has worked out amazingly well in the last year, as you can imagine, and also to have ample space for breakout of classrooms. So you can see that the stairs are actually quite generous in their width. And again, each time you're in a classroom, you get most of the science rooms are viewing toward the sports field, so then you get a view of the sports outside. And then that's through the circulation space as it's moving down. And then the upper level is really the most of the labs, is again, most of them oriented with views, this kind of cellular view out toward the sports field, with a few that are alongside Sutherland Road, which is the perimeter of the campus. So again, that's the big breakout space. Views down that kind of sloping bit. And again, just the science classrooms. And then finally, the roof has occupiable roof space. We've organized all of the fume hoods for all the science labs to come up in one long bar. And then there's also a running track on the roof. That's a view of the roof. The running track, again, on a gray winter day. And that's a view where you're actually then moving up that step up over the science labs with terraces which overlook the field and bring you up to the sea view. You can see just beyond here. That's the fume hood kind of bar there. Now I'll talk a little bit about the facades. This is the Sutherland Road elevation, which is the street view. And it's primarily channel glass with Ocolux insulation, and that's mostly because of neighboring buildings. There are residential buildings kind of along half of it, where the school didn't want to have a feeling of overlooking the neighbors, nor did the neighbors want to feel overlooked. To that degree, we've also set back the balustrades of the roof, so you can't actually get to the edge. And additionally, so that students aren't really looked in on, so there's a degree of privacy coming back. And this is actually an industrial estate, sort of at the lower half, so it's not particularly a nicest of views. So that's actually then the channel glass, and then with each of the labs have a singular kind of window of clear glass for views out, although one of them has a full view, and there are basically moments where you can then get clear glass throughout. There's also a greenhouse, so this is part of the biology labs. And that again then breaks the kind of the hard rhythm of the long building. So it's a view looking down Sutherland Road. That's the greenhouse you can see there, and then most of the channel glass here. Again, we've expressed the skeleton, so it has a dimensional thickness at the elevation, and that has both the channel glass and the clear glass within it. The staircase also is expressed as it comes up the exterior. And then you can see the sports hall, the channel glass is actually flush with the skeleton, and that's to maximize the interior width and clearance of the sports hall, which was set by regulations. And that's just another view looking again up at the greenhouse. The channel glass, I think, had a maximum span of, oh gosh, 12 meters. And so we were just slightly beyond it at the higher points, and so this is actually 2 levels of the channel glass in that position. And then you can see then again the channel glass. This is the running track that comes on the exterior of the building, but then you can see it from the interior here, where again you have the channel glass and then some areas of clear. Then looking from the playing field, again, the playing field level is equivalent to the sports hall here. So this bit is stepped up slightly above it. And then this is actually has all clear glass, and because that's the maximizing that view to the playing field, which was really kind of one of the main key elements of the brief, was to be able to see that playing field and have an interaction with it. And I think, just as an aside, this was a bit of a story that during the competition, the client warned us that the way that the cricket pitch was set up on the playing fields, that we were right in the zone where the cricket balls could come and hit the glass. And we looked at actually glass that was impact resistant, which would have blown the budget for the whole building, let alone just the facade. And we actually went through a whole process where we had some nets that were actually going to be installed all along here. We had some davits that were actually going to extend beyond the building and drop down the nets. And in the end, when we were up at the contractors looking at the actual class samples that we had specified, which were necessary for U values and everything else, actually one of our engineers just said, there's no way a ball's going to break this stuff. And so we actually we did our own impact test resistance, where we got a huge piece of glass on campus and a ball throwing machine and pitched the balls at various speeds, and the glass didn't break. So the client decided to take the risk that the glass will unlikely be hit and be broken, in which case we could sail on that cricket netting. So this is a view then. We can see where the kind of the cellular nature, it's quite clean, where the skeleton is purely expressed, and the glass is really recessed within it as a pure floor to ceiling expanse, and then the kind of wide, high, tall glass that goes all along the sports halls, where you have this, you have the quite high ceiling expression and large spans of those spaces. So that's the aerobics room, the weight room, and the sports hall. And then the sports hall, everything is naturally ventilated except for the swimming pool, which has some forced ventilation, which also has humidity control. But you can see then that the sports hall actually has just doors along it, which give you access directly out to the field, but can be opened also for ventilation, in addition to the ventilation that's provided at the floor through a cavity that's working from some ground source heat pumps. And then the main spaces actually have a major process of ventilation, which is really simplistic, and it's just the greenhouse gets opened, natural air comes in, and natural air goes out. So there's actually just openable windows at the ends of the building and at the corridors. So that's the greenhouse, which is a big open door, and there's a big open door at my back here. And then those open corridors actually end at this, what we call the barcode, and this is just a mesh, quite a fine mesh. So there's actually an openable window behind here, which is just not visible. And then probably the cleverest bit is the ventilation in the labs. So at each laboratory in the corners here, and I'll show you a blown up detail. Air comes in through a small, very small openable door, manually openable door, and it's extracted through vents which are at the roof. If it's sort of occupiable area of roof, then this is actually a vent and a separate light, and in the areas where it's sedum, this is actually an openable roof light, which gives you that ventilation. And so here's the detail, or if you look in, so this is actually a grill here at the fiber C. So it's at the skeleton. This is the kind of the expression of the skeleton at the exterior, half of which, or slightly more than half of which, is a grill, which you can see here. So air comes in, and then it actually goes through a louver, and then there's a small openable, just a really simple Schüco door, which is manually openable. You can see it in the open position here, and then you get fresh air through the room here. And then it's also acoustically separated, so there's no crosstalk between the two laboratories. So that's on both edges of the classroom, which is sort of hidden, just step back between. Each room has a wall of cabinets and storage, and a wall of display for teaching. And so there's one of these at each edge of the classroom, here and here. And then you can see from the exterior, then you get these vents, which are part of the facade and part of that depth of the skeleton. And then that's the roof. That's just the openable, kind of simplistic openable roof lights for ventilation at the sedum roof. And then these are the vents for the rooms at the usable portion of the roof. And that is actually all I have to say. I hope you enjoyed that. Thank you very much.
Thank you very much, Carol. I love the idea of the synergy between sport and science and the effect that that's had on the building. I think everybody watching this would have loved your story about the cricket balls. And I'm going to have to phrase this question slightly carefully. Obviously, in the wake of the Grenfell tragedy, we've seen things where people have really been much too cavalier about safety. But I wonder, in more general terms, do you feel that clients are putting too strong requirements on, that they're worrying about everything and it's kind of down to you to show them that actually this is going to be okay?
You know, I think Brighton are a fairly enlightened client because they've had this master plan and they've built, gosh, I think we're probably the third out of 4 kind of major buildings, or for them major buildings. So I'm not so sure it was Grenfell. I think it was actually the chair of the board, the building committee, who's a big cricket fan. And we're all foreign. I'm American. The others were Dutch and Portuguese. And he said, "You guys don't get this, do you? You put this big glass line right at the..." And it's and honestly, it's not like where if you hit the ball a certain way. And he even took me to Lord's so I could see where the balls went. But actually, in the end, they took the risk. You know, the putting the nets up in either of the scenarios that we were looking at was fairly complicated. It didn't actually do the buildings any favor to have a big net hanging in front of it, even though the actual school year versus cricket period isn't very long. And so it was them that actually said, well, let's just see, you know, if we can't break the glass, then we'll take the risk that it's not going to break and we'll save the money on all those cricket nets. So in some ways they were actually more enlightened than I've had on other projects where there is so much worry about everything that you can't even put a facade on because everyone's concerned about it.
Well, that's great. Enlightened clients is what everybody wants, isn't it?
Yes.
I wanted to ask you more specifically about the cladding as well. You know, you've got this very interesting geometry, and I noticed over the sort of big sports hall you've got the sort of sloping element. And I just wondered, were there a lot of specials on the cladding, or were you able to be standardizing quite a lot, and how you sort of thought that through?
It was very standardized. I mean, we did look at various materials. We did look at GRC or GFRC, whatever and actually the weight of that, because in it being a purist and wanting to be the architect, you wanted it to be one kind of piece, and ideally it would be a C channel coming on the front. And that actually, to make that out of GRC was A, more expensive, and B, the weight of it was so great that it kind of killed some of the structure, had to be beefed up to carry it. And this Fiber C product is a lot, and I don't know the material properties well enough, but it's thinner. And they were able to take it, they could have taken it in certain widths that comes out of the machine and given it a fold where we could have had an L and a piece. But in the end, the cost was just, let's make it flat. And, you know, all the things that we worried about, seeing the gaps where it looks like it's a piece of, you know, too paper thin. You know, it's fine. It worked out well.
Everybody else now is going to come in and join you, and we're going to have a group discussion. There we are. We're all on the screen. And the first thing I wanted to talk about is I've had quite a lot of questions. Retention of structures versus demolition, and they seem to have come from two extremes. Somebody said, should it be made illegal to demolish buildings at all unless there's absolutely no reason, unless it's absolutely impossible to retain them? And someone else said, actually, we should be demolishing loads of buildings because this is going to create jobs, and conservation isn't to do with architectural conservation, but it's really just to do with saving money and keeping things for those sort of reasons. Now, I'm guessing you're all going to be somewhere in the middle. I think I'm going to go to Sandy first, because obviously, you've gone both in this project and in others into places where there has been a mixture of retaining structures and having new builds. What's your view on this, Sandy?
Well, it's I don't think we should be. I think we should be trying to save as much fabric and construction as we can, is my view. I think it's not very green, and we need to do all that we can to save the planet, and this is part of that. And it's also a kind of massive disruption to our cities to cart away demolished buildings and bring in new materials. So I'm very much against it, in the sense that it's not a clever thing, in my view, to be doing at this critical point in the planet's history, and that we should look at like this clever solution that Mark's done at trying to hold on to bits, but inevitably one will find a sick building that has to be demolished, because you can't. It's impractical to save it. And I think there's a lot of clues in architecture and play. We quite like putting modern buildings next to old buildings, and there's a kind of influence and osmosis between the two that we find very interesting. Modern architecture can sit. I always remember it was Bill Howell's pavilion at Downing College in Oxford sat as a little temple in front of some classical architecture, and it just showed that you can do that. You can build modern and work with the old. So I'm in this sort of no camp.
Thank you. I'm going to move on to something else now. A question that came in, which was about circulation areas. And somebody said, should we be heating circulation areas? Or should we just be used to the idea that our circulation areas are colder, and that we're saving energy that way? Now, I'm going to put this to Carol first, and I don't think you talked about this a lot in your project, but obviously in a lot of education buildings, actually, circulation areas are quite important social spaces, aren't they? But I guess they still could be social spaces. You just have your coat on. But have you looked at this, at the heating load on your buildings and whether or not you need to heat circulation spaces?
Well, actually, the Brighton project, everything is naturally ventilated, and the heating, I think, is quite limited in the circulation spaces. However, they are used for breakout. So the intention is that students would be sitting there at a desk with a small group, either doing homework or having sort of small groups at a lab. So it needs to be comfortable. It can't be go sit outside and put your coat on and see your breath when you talk. But it 100% depends on the climate in which you're building, what the actual use is. I can imagine in an office building, but people wear their coats until they get to their desk. So yeah, why not? Why not be a bit colder in the main building circulation spaces? So I think it really would vary on the use and the climate where you are, and even how you manage the layout. The practicalities of that. But yeah, why not if it's feasible?
Mark, is this something you've looked at?
Yes, I mean, we always have this discussion with our engineers in terms of, if we just turn the temperature down 1 or 2 degrees, it makes a big energy saving in terms of how you cool and heat the building. And we always sort of joke, like you suggested, put a jumper on if you do want to bring it down, if you do get cold. So I think, with the way the technology is, certainly when it comes to mechanical components, you can factor those elements in. You can create sort of local environments where you can control the temperature. It gets a bit more sort of technologically expensive, maybe, but I think that diversity of creating environments within certainly commercial spaces is worth exploring. From the circulation spaces to the common areas, to the outdoor terraces. Outdoor space, opening windows is a big hot topic right now, and we were ahead of the curve in sort of that sense, knowing the climate we're in now. And yes, you might have to put a jumper on if you buy the window. So yeah, it's definitely worth thinking about.
Thank you very much. Another question, and we're coming back to the facades. There was a question that came in that was originally intended for Mark, but I think it raises other questions which will be relevant to everybody. And that is, sorry, I'm swaying about. That is about heavy facades. I think Mark mentioned that that you saw a heavy facade with high thermal mass, and the question came in, actually, if it's so insulated and so separate from the building, is it actually contributing to the thermal mass in the building? And I'd like to open that out a little bit more and talk about heavy facades rather than light facades. I mean, obviously, you've used heavy facades, Mark, at St John's College. Wright and Wright also did, and Carol has used a fairly lightweight facade. And there are questions, aren't there, not only about thermal mass, but also about durability. And I just want to know whether it's horses for courses or whether actually each of you has a feeling and will be trying to do the same sort of thing each time. I guess it's really what is a sustainable facade. Sandy, with your Oxford College, which probably wants your building to stand for several hundred years, does that mean that really you want to go for a heavy material, and does that contribute to your thermal mass or not?
They do. I mean, the colleges are caretakers of buildings and have been for centuries. So they want long life, low maintenance, even loose fit buildings. That's very important for them. We're just about to start a new project in Oxford, a library that's built to passive house standards. Gwilym Still, who I think was one of your talkers the other week there, is helping us with that. So I think we can have kind of heavyweight, thick-skinned buildings, but now we're moving into the passive house side of it, which in the long term is the way to go. I couldn't believe the heating layouts when Fordham's presented to them. I said, where are the radiators and the heating coils? And, you almost heat the building with your laptop. So I think having, and the flywheel principle is interesting. So these high thermal mass buildings and stable and highly insulated are, if you can afford them, are the ways to go. I mean, I can imagine Carol had because of designing for schools, which we've done in the past, the budgets are not limitless. And they've got other concerns with running schools, and they're perhaps not as well endowed, as it were, as Oxford and Oxbridge colleges are. But I know I can hear Claire's voice in my ears reminding me that when you look at cost and use, we're too short term. We want returns in 3 or 5 years, but if you look at, and we're doing a lot of studies at St John's into the energy consumption and how it's performing. Is it meeting its targets? Once we get out of COVID and get some students back in, we'll start the research up again. But I mean, I remember Claire demonstrating to a client that over 30 years, if you do this, it'll save you money. Like if you build in good quality materials, you won't be ripping the windows out every 10 years. They'll last for a very long time. So I think people need to think more long term and save the planet that way.
Carol, I'm going to come back to you. What the people watching the webinar couldn't see was you laughing and nodding when Sandy suggested that your clients didn't have as generous an endowment as others did. But I wonder if how you feel in general terms about, lightweight versus heavyweight facades.
Again, I agree with Sandy. How it also is horses for courses. It very much depends on the building, the location, the climate. I think what's great probably about Oxford and Sandy saying is you have a client who has a long history and knows that they're looking for the long term. Whereas I think it's fairly rare that you have a client who really, you often present you could spend this now and save it later. in terms of not even sustainability, but just operating costs. And they usually, because of the tightness of the purse, have to go with the save my money now. Because I don't have the budget to spend now, I won't get the building built, and that's going to be someone else's long-term problem, which is unfortunate. And I think that's something that we just need to, hopefully, with a bit more scare behind them, clients may be making better decisions, or we need to really push them in that direction.
Thank you. And I am going to come back to Mark now. And obviously you've chosen to go for these heavyweight materials. And I think you've also made a sort of very interesting argument in terms of the self-sustaining facade, which actually allows people to make structural changes behind it in the future. But I'm just going to put to you the particular question, which says that actually you've got this heavyweight facade, but you've got obviously great insulation behind it, etc. Is it actually contributing to the thermal mass of the building, given that it's not exposed into the interior?
Yes, which is also why I showed the slide of the interior as well. So the outer masonry in the precast component does act as a thermal absorber of the solar gain, the external heat. Yes, you have your insulated airtight box behind, so that energy is released back out into the environment as opposed to absorbed by the curtain wall. But internally, where we expose those structures, expose the concrete soffit, that energy that's internally used or expelled is absorbed and slowly released again into the office spaces. So there is a play on thermal mass, thermal inertia across the board, not specifically just the facade. And I hope that answers some of it. When you come to the retained facades, again, the outer line acts as a thermal damper, as it were, to the new inner lines on the inside. So on balance, we feel that's, I think more can be researched and done, but certainly the exposure of, so we say, self-finished materials helps towards this play on thermal inertia within the building.
Thank you very much indeed. We are getting great questions in, but I have to say a lot of them on really big philosophical issues and things that we could actually be discussing, not for the next sort of 5 minutes or so, but probably for the next 5 hours. So I'm going to put another question, and I guess we need to try and answer it fairly fast. How do the panel members actually measure and benchmark sustainability success on a project by project basis? Carol.
Oh, that's a good one. The standard is BREEAM or LEEDs or various other tick boxy, but I think we all know that those aren't necessarily representative of the true nature of how a building is properly sustainable. I mean, it is an exercise where sometimes you feel like you're doing things to tick a box off to get your BREEAM excellent, as opposed to it being the sensible thing to do in your building to have it be more sustainable. Ideally, and again, not every client wants it. It sounds like Sandy's doing it at Oxford is a post-occupancy evaluation to really see if all of the measures that you've assumed really are accurate in practice. For us, I think, on Brighton is actually interesting because a lot of the things are manually operated. All those vents are for the teacher to control. So it's not a BMS system that's opening things. It's actually, my classroom feels stuffy, I want to open the window. And does it then someone need to go back and close them? So this is a question, is it really, I don't know the answer to that because the buildings, we always had COVID, so it's not been occupied in the same way that it would have been in a regular school year. Ideally it would be the post-occupancy review, but we don't get that on every project.
Mark, what about you?
Yes, I think so. Carol touched on the right thing. It's sort of going back to revisiting your projects, taking that data from the occupants out there and checking it against what you designed it to, and seeing if it's outperformed or performed better, performed worse through its use. So we're doing that a lot for our current projects as we go forward, and we will do that for AT Charlotte Street as well. usually have to do to get your energy rating. You have to have a year of operation before you get that certificate. So it's not quite occupied yet. We've got PC sort of March this year. So we're running that analysis, and it's only just been fit out and occupied as of last month. So we will be running that analysis. But we have done it on other buildings, as a sense check to see whether, we're not just meeting the checklist, as Carol mentions, but also trying to go further. I think designing buildings that, last long or are flexible, especially from a commercial perspective, is very important. Our building might be the retained facade of the future, or or ideally not. There's enough floor build up that you could just put in a new bit of kit, or adapt the use in a future date to come. And I think that's really important to get that longevity. If you're going to put a lot of carbon in, I think it's got to last a long time, which then determines the type of materials you use, where you place it, and how you use it. So I think there's a few strands of thought that go into these sort of metrics of analysis.
That's really interesting. And I'm going to come on to Sandy now. And I think that's interesting where Mark said, if you're going to put a lot of carbon in, you've got to get a lot out. I mean, part of it obviously is this balance, isn't it, between embodied carbon and carbon in use. And although you can, in your case, probably, Sandy, discount it over centuries rather than decades, it still is going in now. But you're obviously on a journey when you talk about, you've done this library, which has got a great performance, but then you're going on to do a library to passive house principles. How do you measure and benchmark, and how do you see your progress in those terms?
Well, the St John's Library we had a higher target than building regs, and Fordham's were very helpful in helping us with that. The Passive House is new ground for us. We're doing a lot of projects, and all the guys in the office are going off on courses to learn more and more about it. I think other things I would add to this thing, that buildings don't stop at practical completion. They start changing. The minute you hand them over to clients, they start changing. Does the shoe fit? And only by testing it. But the industry, everyone, your sponsor and everyone, and all the designers need feedback on how buildings are performing. And I think if the government's worth its salt, I mean, it's coming out with big political jargon about being green, but I think they need to put their money where their mouth is and help the industry and help everyone, whether it's a tiny primary school with low budget, help us sponsor feedback so we can monitor how buildings are performing in the future. And we can bring that all together, and we should all share it. So that we can get more and more efficient. I mean, this economy's, it's good. We're all in commercial companies, but I think there's a lot more sharing could go on to improve the general standard for large and small projects and rich and poor clients. I think the government or somebody needs to, take charge of this thing and drive it. Maybe it's on the energy conference in Scotland that's happening later this year. I don't know. But I mean, buildings don't stop. I mean, you do mock-ups to build buildings. We've all talked about mock-ups to build buildings, but I think you test and research the thing in use. That's where it gets exciting and interesting. Does it work? Does it do all the things it said in the label?
Yeah, I think that's really interesting. And I think probably, here as everywhere, we do tend to talk about the building that's newest rather than 10 years old. The problem there is, of course, that it was designed to lower standards. But I think at least we can't be as rigorous as a kind of post-occupancy evaluation that is obviously desperately needed to be learnt from. But I think at least we have shared some knowledge today, and I think we've given people a lot to think about, certainly given me a lot to think about. So I would like to thank all three of you for taking part. I also like to thank everybody who has been watching and has sent in questions. This will be available to see again. And finally, just on behalf of Architecture Today and Schüco, I would like to say thank you very much. It's been a great morning, and I hope everybody else has a really good day.
Thank you.
Thank you.
Thank you.